Good morning, dear students. Good day, good afternoon. So, today we're gonna learn about the heat engines and we are going to study how to calculate the efficiency of heat engine. I think you know how heat engines work. So you remember that heat engines they take heat to do work. So heat in this case is called as total input of energy, and the work is useful output. So input is what we give in, work is something we take out of this energy. So the energy that we give in this example is it comes from hot reservoir, and it is equal to 100 kilojoules. Initially we have to know that the gas is cold, and after heating this gas, the gas becomes hot and it increases in volume, so it expands and does some work. Okay, so in this case this is our input, this is our input and this is our output. We know that the input here is 100 kilojoules and output is 20 kilojoules. The question is where the remaining 80 goes. Yes, the remaining 80 kilojoules of heat, it goes to heat the gas. Okay, the gas is heated and the temperature has increased. In order to repeat this cycle, so in order to do this process once again, we have to bring the gas for the initial state. We have to cool the gas, okay, so that the gas is cold again as it is here. So we have to take the heat out of the system. So that's why we need cold reservoir. In this case, cold reservoir takes 80 kilojoules of heat, and after that it returns back to the initial state. Okay, and in this case we can repeat the work of the engine again and again. Here you have to know that our input is the heat taken from the hot reservoir and our output is the useful work. Okay, so the quality of heat engine is determined by its efficiency. So efficiency is useful output divided by total input. In this case we have to write this here. Useful output is work done by the system, okay, not on the system, and that total input is heat taken. Okay, heat taken. Useful, yes, this is work done by engine. The total input is QH. Okay, so heat taken in this case is denoted as QH. Okay, and the work done is by W. From the energy conservation, yes, you know that work is what the heat taken from the hot reservoir minus heat lost to the cold reservoir. So finally we will have the efficiency. So the efficiency is denoted by this letter. Here it is equal to W divided by Q hot. We know that W here is equal to Q hot minus Q cold, so we can write the efficiency in this form also. Also we can write the efficiency in the following form. So sorry guys. So if you know that we can divide Q hot by Q hot, we will have 1 here minus Q cold divided by Q hot. Okay, that's another possible formula for efficiency. Okay, so now let's solve one question to better understand this topic. So in this question, heat engine absorbs 100 joules of heat, so it means that our Q hot in this case is equal to 100 joules, and 40 joules is converted into useful work, so it means that our W is equal to 40 joules. So here in A we have to find the heat released, so we have to find Q cold, and the part B we have to calculate the efficiency of heat engine. So what do we do here? So here we have from the energy conservation, so W equals Q hot minus Q cold. Okay, so and if we substitute the numbers here, we will have W as 40, Q hot is 100 minus Q cold. So from here we can calculate that Q cold is equal to 60 joules. And now we have to calculate the efficiency. The efficiency can be calculated as work divided by Q hot. So our work in this case is 40. And we divide it by 100, and we will have 0.4 efficiency. So this basically means, sorry guys, so if we have efficiency of 0.4, this basically means that our efficiency of engine is 40%. Okay, so you take this number and multiply it by 100%, and you will have finally 40%. Okay, so that's it. So now solve problems. Good luck.